Hi, Pre-Calc. We are moving on from the factoring unit that we started with at the beginning of the year here, and we're going to take a look at, for the next few days, how to simplify complex fractions. And this will actually be a pretty short lesson because this is going to be a lesson that gets combined with our first quiz that we have coming up here. So for complex fractions, what you want to be able to do is analyze that we have fractions within fractions. So we have this fraction right here, 4 over x, and that's being divided by 3 over 2x. So to simplify complex fractions, there are a few different methods that you may choose, but the one that I like the most is I like looking at the two denominators currently of our individual fractions. And then what we're going to do is we're going to identify what the LCD is for those denominators. Whatever the LCD is, we're going to multiply the top and bottom by the LCD in order to simplify the complex fraction. So in thinking about the LCD for this first example, the LCD, hopefully you can recognize pretty quickly off the bat, is 2x. And you'll know, I guess, if you have not identified a common denominator when you get to this next step where you multiply the top and bottom by 2x. Now, as a reminder, why are we allowed to do this mathematically? When I multiply the top and bottom by the same quantity, it's sort of like multiplying this whole thing by 1. So mathematically, this is a legal step that we can take. So when I multiply through by the LCD, in this first example, the x on the top and the x on the bottom will cancel, and we're left with 4 times 2, which gives you a numerator of 8. In the denominator, the 2x's cancel completely from top to bottom, and it just leaves you with the 3 up in the numerator there. So the simplified form of this complex fraction number 1 winds up being 8/3. Moving across to number 2, it starts to look a little bit more complicated. There's no variables here, but we certainly have a lot more fractions to kind of work with. So what we want to do is, with all 4 fractions that I'm seeing, is look at all of those denominators, 5, 3, 6, and 2, and figure out what is the LCD that would work for all 4 of those. And I'll give you a second to think about it. If you want to hit pause, you can. But the LCD for number 2 should be 30. Okay, so 30 winds up being a factor of all of these. Now, here's the only difference between what I like to do, just because it's a little bit simpler, and probably what you're used to last year in Algebra 2. I feel like a lot of Algebra 2 lessons that I see have 30 written next to each individual fraction. So there's a 30 here, a 30 there, a 30 here, a 30 there. Because what's happening is that your teachers last year were already distributing the 30 for you. But I feel like now that we understand what complex fractions are, we can probably just write it that we're multiplying the top by 30 and then the bottom of the complex fraction by 30 and do a little bit of the distributing in our head. Okay. If you like the old way from last year, go with it. Not a big deal. Because 5 goes into 30 6 times, and then 6 times the 2 up in the numerator is 12. Plus, moving on to the next term, 3 goes into 30 10 times, and 10 times 1 is 10. Going to the denominator here, 6 goes into 30 5 times. 5 times 5 is 25. And then 2 goes into 30 15 times. 15 times 1 is 15. So certainly we have something that's no longer complex. We have a single numerator, a single denominator, but we should just clean it up by combining like terms. So what's that going to be? 22 tenths. And 22 tenths can reduce to 11 fifths. So we don't have to be necessarily all that worried about if there's more than one fraction on the top and bottom, but you do have to make sure that with each and every single denominator, you've identified an LCD that works. Even if it's just a common denominator, you can still reduce this in the end, but it has to at least go into all 4 of these. And hopefully it is the least of those common denominators. Moving on to numbers 3 and 4 down here. For things that don't look fractional, sometimes students like the look if you put 2 over 1 and 4 over 1 down there. That might be a little bit of personal preference. It's not a required step, but now it looks like we have 4 fractions, and we want to figure out what is the LCD with all of our denominators. The ones I'm really not too concerned with, so I really just want to look at comparing the LCD between x and x squared. And the least common denominator, if we were trying to establish one here, would be x squared. So once I multiply the top and bottom by x squared, you have to think about what happens when I distribute that x squared across the top. Well, 2 times x squared is just 2x squared. Here, this x is going to cancel with one of those x's. So the resulting product for the second term is going to be a plus 3x. And then moving on to the denominator, distribute the x squared to get 4x squared minus, here notice how the x squareds cancel completely to leave you with minus 9. Okay, once we have that set up, we're not quite done, because what I'll tell you is once you get it down to a non-complex looking fraction, you still have to consider, can I simplify this any further? And if you look at the numerator, we can factor this. So factoring is not leaving us anytime soon. We're going to take out a GCF of x on the top to get 2x plus 3 left over. In the denominator, we have difference of perfect squares, which is 2x plus 3 times 2x minus 3. And then our final simplified complex fraction is x over 2x minus 3. All right, one more kind of similar to that. Number 4, we have 2 over y minus 1, and then 1 minus 4 over y squared. Again, if you kind of like the look of putting those 1s over 1s to make everything look like a fraction, completely up to you. But we're going to multiply through by the LCD on top bottom. LCD in this one is y squared. It's a pretty similar looking example to number 3. So hopefully it was going to be easy for you to identify that LCD in this one. Okay, distribute the y squared across. So you're going to get on the top, this y cancels with one of those. So the first term would be 2y minus 1 times y squared. So that's just y squared. On the bottom, distribute the y squared in to get y squared minus 4. And then just like we did in the last scenario over here, once you get rid of the complex fraction, you now have to simplify and see if you can factor and cancel. So I'm going to take out a GCF of y in the numerator. That's going to leave me with 2 minus y. And then the denominator factors with difference of perfect squares into y plus 2 times y minus 2. So the question naturally here becomes, can I cancel anything? And the answer to that is yes. The 2 minus y and the y minus 2 will cancel out, but you're left with a -1 factor. So what I mean by that is if you were to factor out a negative from this whole expression, I'm actually going to take that negative and put it out in front of y. This would become y minus 2, right? I mean, if I take a -1 from here, it becomes positive y. Factor out a -1 from there, it becomes a minus 2. Do you have to show that step of factoring out the negative? In my opinion, not necessarily. But when you cancel a 2 minus y with a y minus 2, you have to indicate that you're left with -y up top. And then y plus 2 in the denominator. There's my final answer. That is a step that students do tend to forget. Sometimes they get the question, could we also have put the negative with the denominator? And the answer is yes. For personal preference, I usually just leave it up top with the numerator. But it would not matter if you put the negative with the top. If you put it on the bottom, you would just have to leave the y plus 2 in parentheses so that it belonged to the entire denominator there. And finally, I think there's just one more question in this introductory lesson here. For number 5, you'll notice we've now extended the way our complex fraction looks even just a little bit further here. Again, if you want those 1 over 1s, go for it. But the main denominators that we're looking at here, we don't really care about the ones, but we've got a and a squared, both on the top and the bottom. So altogether, the LCD for number 5 is a squared. Okay. Go ahead and multiply the top and bottom through by a squared. We're going to expand it out this way. So distributing a squared to everything on top. Just be cautious here. 1 times a squared is a squared minus, here this a is going to cancel with one of those a's. So the middle is 1a. At the very end, the a squareds cancel completely, so you're just left with minus 20. Distribute across the bottom to get a squared plus, this a cancels with one of those, so the middle is 8a. And again, a squareds cancel at the very end to leave you with plus 16. And then, of course, we're going to stop here and ask ourselves, can we go any further? Can we factor the numerator and or factor the denominator to simplify this fraction? And these are, I would say, pretty straightforward trinomials that we can factor. We want things that multiply to negative 20 but add to negative 1. That's going to be a minus 5, and then a plus 4. Multiplies to 16 but adds to positive 8 would be a plus 4 and a plus 4. If you want to write that as a plus 4 squared, you can. Just know that when I cancel a plus 4 from the top, you can only cancel it with one of the factors of a plus 4 in the denominator, right? So your final answer would be a minus 5 over a plus 4. And that's it. So there's your first lesson on complex fractions. We'll be working on the complex fractions homework the next time I see you. Have a good one.